Good morning, mates. The next exercise that we are going to solve is exercise 3.2 of the fundamentals of electrical circuits. Here in this exercise we are asked to determine the tensions B1 and B2 EHH previously indicated. So the first thing I always recommend is to do a visual analysis of where the currents enter the node and where they leave. Remember that Kirchhoff's current law tells us that the currents entering a node are equal to those leaving. Some do an analysis saying that the currents that are the sum of the currents of a node are equal to zero. EHH, well, first thing to do, or what I recommend, is to do a visual analysis. For example, I'm going to stop here at the B2 node. I stop here because it helps me do the analysis, since the current of 6 amperes enters that node, the current of 3 amperes. The two currents reach this point and have to take their path somewhere. Now, as this part, the reference, our mass indicates that here the voltage is zero, therefore here it does not exert any force contrary to the flow of current. So I say this way. A current is going to circulate, and when it reaches this node, well, I say well, a part of the current that enters that node comes out from there and the other part that goes is this way. Now this current that comes from here, well, it continues its path here until it reaches node B1 in that node B1. Well, I'm already seeing that this current that I'm marking now comes in. Now we're going to give it names and this current comes out. So there are two resistors that we need to analyze how the current flow is. Now, since I say that this part is more and is equal to zero, there is no tension here. Therefore B1 in a certain way is greater than zero. We still don't know if it's true, but it's a valid deduction since it's zero here. So now with the analysis we will know how much B1 and B2 are worth in relation to more. And this is where the current comes. This is where the other current comes. Now in this is current I1 and as current I2. I'm already giving it names. I'm going to call this the current I3, which is going to be equal to this current and 3, and here I'm going to call the last one and 4. Ready. Then I'm going to do the analysis in node 1. I have here node 1. The currents that enter through the only one that enters is I3. I'm going to put all the currents that come in. And 3, this is going to be equal to all the currents that come out. So for this one I don't see what the amps are for the amps. The current comes out and 1 plus the current I1 and the current I2 comes out for the current I2 ready at that point 1234. Now, the current I3. Let's notice that it has this address. If I mark this direction it is because the voltage V2 is greater than the voltage V1, so the current I3 will be equal to V2 minus the voltage V1. On the resistance of 2 ohms it will be the same. Remember that this here is current I3 is what represents the current, and 3 above is the voltage up to the resistance equal to 6 amperes plus T1, but the current one. Notice that it has this direction, because the voltage V1 would be over 10 ohms, right? We could omit the units and in the end we put them here in the stream. Then add the current I2, which is the voltage B1. B1 again over 5 ohms. Ready. Now, this will leave us with an equation of 2 unknowns. So I'm going to leave, well, I'm going to leave the variables on one side and the constants on the other side. I'm going to leave this here. I'm going to leave it on this side and I'm going to move the B1 from this to the other side. But first let's organize. So I'm going to separate B2 over 2 ohms minus B1 over 2 ohms. If I separate this, it will be equal to A26 AP1 over 10, more than 1 over 5. Well, we are like this. Well, let's continue. I'm going to turn this down a little bit. 4. To have more space, and I continue. So here I'm going to stop here at this point, and I'm going to put this aside. I'm going to pass this over there. This is her too. And then I pass this back and forth. Here I'm going to put B1 the same. Out of 10. More B1 out of 5 than these two. I'm leaving it here and I'll pass this on to the other side. So I would stay B1 over 2 minus B2 over 2. I'll pass it on there anyway. It would be minus 6. Okay. So notice that here we have B1 over 10 plus B1 over 5 plus B1 over 2 minus B2 over 2 minus 6. This is the same as having 1 out of 10, 1 out of 5 plus 1 out of 2. If you want to put the units, we put it by B1 B2 over 2 equal to minus 6. So if we overcome what is here, it will give us 5/4. Please check the calculator. 5/4 is not 4/5. 4/5. If you want, check it on the calculator and you will realize that it is okay. Minus B2 over 2 minus equals minus 6. Now we can give this like this, but if you want, and this is optional, we can multiply the entire equation by 10, both on one side of the equal and on the other to maintain equality. This in order to eliminate the denominator and have a much larger number. More clear. So, if I multiply the entire equation by 10, multiply 4/5 by 10, this will leave me with 8 of 1 less. Here I will have 5 B2 equal to minus 60. Both this and this are fine, except that here I avoid the denominator but not the equality is maintained. This is going to be our equation 1. Okay. Now we're going to do the analysis of the second node. We did the one for node 1. We are going to do the one for node 2. I'm going to copy this. And I'm going to paste here. I'm going to paste here. I'm doing that to get on this side for doing the node 2 equations. Here I come. To experience this, I'm going to put node 2 here. In node 2 we have the incoming currents. We are going to mark the first ones, which would be the 6 amperes, the 3 amperes, which are the currents that enter at this point, and those that leave. We had said that it was good o'clock and 3 and o'clock and 4 o'clock and 3 that came this way. What is this same? And 4 past that comes here. So the Y3 is the voltage here, the voltage V2 minus the voltage V1. Well, first let's get the right one. It would be Y3 plus Y4. So 6 and 3 are 9, but there are still 3 as B2 and V1. This is about 2 ohms. plus the N4 would be V2. About the 4 men. Well, then here I would be like 9 equals AP2 over 2 minus V 1 over 2 plus P2 over 4. Ready? I have minus V1. Perfect. Now I'm going to operate. Hey, well, I'm going to arrange the equations. I'm going to have minus V1 over 2. Hey, more fingers. About 2 more than 2 equals 9. If I add this, it will give me 3/4. I have less left. V1 over 2. Hey. Plus 3/4 of V2 equals 9. So, if I multiply that entire row by 4, I'm going to get 2. Because I multiply it the same to eliminate the denominator. That every time you can. But up here I have minus 2b1 plus 3v2 equal to 36. Here I have my equation number 2. Now, I have both equation 1 and equation 2. I'm going to mark it here. Here is equation 1 and I am going to write this same equation down here to leave the two indications V2 V1 plus 3 V2 is equal to 36 for the one in equation 2. Here we have two equations with two unknowns. We can now use the solution methods on the calculator. There are calculators that solve it in one go so as not to make the video so long, right? Well, they can use whatever method they want. I could use elimination, Jordan substitution equalization, or a better analysis that can be done on these circuits is going to be Kramer's, right? Depending on the solution method that you have, you will see that the result will be that attention 1 is equal to 0 volts and attention 2 is equal to 12 volts. If you would like to know any of the solution methods that I previously showed you, such as Kramer's, which is one of the most used, please leave me in the comments and I will gladly make a video on how it is applied. That solution method. Ready. So the attention at B1 is equal to 0. Attention B2 is equal to 12 volts. Ready. This is the solution of that circuit.